Hello, y'all. Darryl Berry Jr. back for some review of some nonsense. And actually discovered earlier that there's a debate on gravity going on tonight on MDB. So I think instead of doing the Veritas this week, I'll review that. I'm going to change my time frame on the Veritas one so people's not looking for that one. Maybe I'll make it next week or something. Uh, but yeah, look at this, at least some of this gravity debate. I'll see how much I'll get through. I feel like I can use a break. So, oh, hold up. Did I click the right one? Let me see. Review. Okay, so an impromptu change, making sure everything changes properly. Right, so that looks good. I set uh the one for Veritas for next week, and I have the one for the uh gravity debate going on right now. So I'll check that out and see how it goes. So of course I like the topic gravity. Of course it's something that the flat earthers uh either lie about or just totally misunderstand. So it'd be interesting to see. So I'll go ahead and load the uh screen. We'll see what it's talking about. So it's between Flat Earth Aussie and Grayson. I remember I saw Flat Earth Aussie. I wish I'd have noted which debate that was in. But I remember him saying something to the effect that he believed he was the smartest person on earth or one of the top 10 or something like that. It was amazing. If anybody's watching and you know what debate that was, please let me know. It's a clip I would like to see again and see how that conversation evolved. Um, there may still be a debate that I have in I guess a week or so now. I haven't heard anything back yet on it, so it's probably not going to happen, but we'll see how it goes. Um, been real busy with school, so haven't been doing any extra streaming. The semester is almost going to end, so for a while I had three classes at the same time for a week. I finished my modern physics class, which reminds me I'm going to do a presentation on some of the experiments I did in that class. Of course, you know the flat earthers delude themselves and believe in their research, and all they do is just like watch a meme, something, and then just believe the meme and repeat it mindlessly. Of course, you can't tell them that. They believe that we just repeat stuff mindlessly. The lack of self-awareness is amazing. But I actually plan on uh, making each experiment. I mean, it could be talked about briefly enough, maybe like 20 minutes on each experiment, maybe 30 minutes on each experiment. And I gave a talk. Some of you may have seen it on dark matter and dark energy in several places, amongst others on MC Toon's channel, which was awesome, which was fun. Big fan of MC Toon. He said he's happy to have me back, so I'm thinking about going back to his channel and talking about some of these experiments. Maybe I emailed him today, see if we can set a date for that. I have all the data for the experiment. I'm actually working on another experiment right now with solar spectra, getting the spectra of the sun, taking pictures. Some of you who go to my site, you know I like to take pictures of the sun. I'm also, perhaps, if I can get the equipment to do it, try to see how fast the sun is spinning. I mean, I could do it to a certain extent by looking at the way the spots move around the sun. At least theoretically, I can. Theoretically, in the vernacular sense. Uh, when one of my professor for the modern physics class was saying he was intending on taking a device to get some very high precision spectrographs of it of the sun and basically looking at the Doppler shift on either side, which is the official way to do it. That's the way to do it with distant stars, so it'll definitely work on the sun. Matter of fact, if I remember right, my stellar, what was it? Stellar astronomy class. the professor showed a uh, sort of a Doppler shift image of the sun in that respect. So, but without further ado, I'll take a look at this debate. I actually started watching it earlier, right before the stream. I was going to talk about the Veritas one, but I was like, I feel like continuing to watch this. So maybe I'll spend like an hour and a half. I'm not sure how long they'll end up going. As far as I know, it's still going on right now. But I'll click back and start watching the actual opening and everything, and we'll see how it goes. If anybody's watching, drop a line into the chat so I know you're here. I know there's at least one person here. Drop a line, say hello. And here, letting you know I'm watching the chat. And I'll definitely respond to people who drop a line. Last time I had a nice discussion with one of the viewers. So without further ado, and I'll start the volume low and increase it as we go, because I know when the first time I did this, I didn't like the way the volumes were balanced. So I'm always watching that now. So if you're watching, if you watch live, then let me know if I need to adjust the volume if I miss something. So let's see what we have.
Wasting time.
That seems to be about the same volume that I'm talking.
Hey,
I'll move
everyone,
a
we
little
are
bit
here.
closer to the
Welcome,
mic.
everybody, to Modern Day Debate. Tonight, we're going to be debating, is gravity a hoax? And we have Ross here, Iron Horse, to get us started. So you have up
Another
to 10
Ross.
minutes on the floor. Thank you so much for being here, Ross, and it's all yours.
Yeah, thank you, Ryan, and thank you, Grayson. This was a rather impromptu debate. It only came up at the last minute in the last day or so. So I've written a quick introduction this morning. I'll start right away. A big thank you to Modern Day Debate for hosting this rather impromptu debate. My opponent, Grayson, for being so brave, speaking on a topic that history is no doubt going to thoroughly laugh at, that intelligent human beings once cling to as modern science. The cogs of dissonance grind slowly, and I'm here to douse them with good oil in the hopes that mankind can finally return back to sanity. A 14th century English philosopher is recollected in every thinker's mind when deciding which explanation is usually the best one, the simplest. While he himself cannot be attributed as the direct author of these words, enti non sunt multiplicanda praeta necessitate, the spirit of his law and parsimony translates as, entities must not be multiplied beyond necessity. This is the spirit of Occam's razor. Famous inventor Nikola Tesla is renowned for multiple game-changing inventions and is often quoted, sometimes falsely, sometimes out of context, but it cannot be doubted what he meant when speaking about modern scientists of his era. When speaking about Einstein's relativity theory, quoted in the 1935 New York Times, Einstein's relativity work is a magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. Another lesser-known quote by Questler goes, "We are all one. People are interconnected by invisible forces. Although we have freedom to think and act, we stick together like stars on the heavenly arc with unbreakable connections. These connections cannot be seen, but we can feel them." Before I move on, I find these words of wisdom most timely as well. Of all the forces of friction, the one which mostly slows down human progress is ignorance, the thing called by Buddha the greatest evil in the world. So, is gravity a hoax? For that, we must ponder several possibilities. A, it's a deliberate, deceitful hoax created by evil people to fool all mankind. B, it's an accidental hoax created in good faith by men trying to make sense of a world based on accidental or deliberate false premises. And C, it really isn't a hoax at all. It's truly a force unto itself, even if still not completely understood, and maybe someday we'll grasp a better understanding of it. Let's address point C first, as that's really all my opponent can claim and support anyway. The inverse square law of gravity, first proposed by Newton, says that the gravitational attraction between two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. In other words, the force of gravity is inversely related to the distance between objects. This presents as a huge problem for the spinning spaceball proponents because, yes, indeed, this is absolutely a flat Earth versus globe Earth debate, and gravity is one of the key necessities of the globe's existence and, obviously, its greatest weakness. People like to say that vacuums don't suck, and while you can argue that one way, it's a bit like the push me, pull you. It's a two-way equation where neither explanation is right or wrong, yet both are simultaneously correct. The atmospheric pressure seeking equilibrium is the reason why, when a valve is released to let air back into a vacuum chamber, forces itself back in with great veracity, but it's equally true to say that the void within is sucking the air in. This can be demonstrated with a multi-tier vacuum chamber here on Earth, where, due to distance, gravity must necessarily be strongest. I'll use a 3-tier chamber for simplicity. The same principle applies no matter how many stories are added above. All 3 tiers can be operated remotely and sealed off from one another or opened up. At first, the entire chamber is evacuated of all air. We'll call the ground floor chamber section 1, then upwards to 2 and 3. They are sealed off altogether, then some amount of pressure is allowed into chamber 1 and sealed off again. Let's say we permit 10 psi of pressure into it, which means against every wall, floor and ceiling of the chamber, the gas is exerting an even pressure in every direction, equivalent to 10 pounds for every square inch of surface. Normal atmospheric pressure being a little over 14, so it's almost 2/3 of normal air pressure we don't even feel outside. If we now release a valve into chamber 2, gravity is absolutely powerless to prevent the pressure from going upwards and equalising with the void. In the principle known as Boyle's law, gases in a container exert equal pressure in all directions. And now, throughout this entire space, we have a pressure gradient of just 5 psi in all directions. Gravity did nothing to maintain a higher pressure at the base, as it's said to do all throughout the entire surface of the spinning space ball. When we open the 3rd chamber, the same occurs again. Gravity is useless in holding individual gas molecules downwards. Their very nature is to be free to roam and, in accordance with Boyle's law, fill every available space evenly, now creating a psi of roughly 3 1/3 throughout the entire enclosed space. If this is how gravity behaves when it is at its strongest, it becomes impossible to describe how the planet maintains a pressure gradient all the way to the void of space, not just because gravity itself must get weaker and weaker, but also because to necessitate the reality of their fantasy ball going around the sun, it's not just the daily rotation of 25,000 miles on its axis we must concern ourselves with, but the very necessary and impossible orbital speed around the sun. While actual rotation is merely 1 1/3 the speed of sound, anyone who's ever watched footage of a railgun projectile understands the mind-boggling speed of a projectile moving some 8 times the speed of sound, where it effortlessly pierces layers of reinforced concrete and steel-plated barriers like a hot knife through soft butter. And it is often able to reach targets over 100 miles away. Something impossible on a 25,000-mile circumference globe where there would be well over 1 mile of curvature drop hiding any possible target. Even the world's tallest building stands at just half a mile tall, the sort of curvature drop that should and must occur at just 60 miles of distance from any and every point on Earth's surface. However, the helioists, dressing up their beliefs in mathematical garb, claim that their obloit spheroid maintains a constant speed some 10 times faster than this projectile in order to go around the sun for every 364.2 rotations of the globe on its axis, which segues neatly into our next point, where all dropping objects said to be free-falling in air at 9.8 metres per second squared must necessarily fall in very specific sideways direction, different for every time of the day and different for every latitude, in order to keep up the illusion of dropping straight down and always maintaining that constant rate of acceleration. Here's my crude diagram here. Hopefully can be seen. We can see that objects on one side of the globe must necessarily be racing upwards faster than Mach 88 minus 9.8 metres per second squared, which would be on this side, in order to create the illusion of falling down. The objects at the rear are going the opposite, Mach 88 plus 9.8 metres per second squared. The objects moving forward on the sides must intrinsically know which sideways direction to fall at least 30 times faster than 9.8 metres per second squared, just to create the illusion of falling straight down. Meanwhile, on the other side of the planet, they're doing the precise opposite. People talk about raising the dead, walking on water, or turning water into wine as some sort of great miracle. But really, the everyday event of inert, dumb objects knowing intuitively exactly which direction to fall in order to create the illusion of only ever dropping straight down would have to be the greatest miracle of all time, yet we simply take it for granted. It's not that we don't believe in some sort of force to cause the universal up and down directions we observe here on the stationary planar Earth. However, while the true reason is still often debated, I personally find no greater explanation is required apart from relative density. The Earth appears flat and stationary because it is flat and stationary, and objects appear to drop straight down, give or take wind assistance, because they do simply drop straight down. An object in motion stays in motion unless another force acts upon it. Therefore, an object in free fall motion in a vacuum will drop forever unless some sort of force prevents it. This prevention force can be called resistance, and resistance comes from substance, from something tangible that we call mass. Even air itself has a resistance force, the reason why any accelerating object in free fall will eventually reach a terminal velocity and eventually come to rest, hopefully gently with the aid of a parachute in the case of skydiver, when reaching solid ground. the place of greatest resistance. Resistance is a force due to density. Density can be described as the molecular makeup of the various elements from hydrogen as the least dense, increasing by increments all the way through to osmium, the densest naturally occurring element. We generally think of lead, gold, or mercury as the most dense among metals, while metals like...
What's going on already? Ready says Ross loses every debate he participates in. He's uneducated, dishonest, and completely ignorant of anything scientific. Well, I'd agree. Customary of the flat earthers, and I'm trying not to comment on too many things because Grayson probably will hopefully address a lot of it. But you can hear him throwing around words like Boyle's law. I doubt he has any idea what he's talking about. Just like in my debate with Toby and Alan, how me and Tony against Toby and Alan, how they was throwing around words, having no idea what the hell they're talking about. They just learn words and just throw it about like relativity and having no idea what a reference frame is, no idea what proper time is, like I showed. We have to apparently understand relativity so much, like somebody commented on the video, that they know Einstein is wrong. And they're talking about the paper, but don't understand what a Taylor expansion is. So they have no clue what they're talking about. They just learn certain words as buzzwords and just throw it around. So it seems to me that this is what he's doing as well. I can certainly see him not knowing what he's talking about, but I'm not familiar with Grayson, so I don't know exactly. I mean, I saw a little bit of his little opening part. And I backed up and I'm reviewing through what I saw already, so I could say with you all. But he's going to say that he debates a lot and debates a lot of denialists on various things. So hopefully he addresses these things. And thanks for joining, Splurge and Ready. Make sure you like, subscribe if you haven't already. Thanks for joining. Hopefully you saw some of my debates as well. See where I'm coming from. And Ready says Grayson will take care of him. Awesome. Grayson has a good head on his shoulders. So that sounds good. So we'll see. Hopefully he does well. I mean, he seems sharp. Just seeing his background, he has like he looks like a DNA helix. Has some books. So flat earthers. I mean, I think I don't know if they could read anything longer than the meme. I think if you give them something longer than what could fit on the meme, I don't really know if they will be able to read it. I think their brains just explode if it's longer than a meme or something. So the fact that he has books, I mean, I think flat earthers, if you hand them a book, they might like melt, like that old Wizard of Oz when the witch when you wet the witch and she just like melts. I think that's what happens with a flat earther if you give him a book. So the fact that he has books, the fact that he has the thing of a helix and there's a globe looks like on the side as well. So and also he has his what is that called again? Is that the equidistant? I forget the name of the map. We got this little flat Earth map in the back, so we'll see how it goes.
Like aluminium.
Now, one thing I do want to say, I mean, Flat Earth Aussie's opening was just a drone of just him just ranting and throwing little jibes in. But he did mention a few times that it's an impromptu debate. I've had MDD contact me impromptu, and depending on what I'm doing, like I'm in school, and sometimes I might not check my email for a week. And I have had an instance where like I went check my email and like let's say 5 days ago, MDD was like, "Hey, we have a debate like tomorrow. Can you join?" But it was like a week ago, and I just didn't check my email during that time because I was like writing a paper or something. So he probably just contacted them like they said like the day before. So I guess he could be to a certain extent excused for not having something very much prepared. AEMAP, thanks, Spurge. Yeah. So maybe I should start learning those names, but I guess I'm more about content than names. I don't just flat earthers. I guess they're real good at just learning these buzzwords. Well, we didn't know that map doesn't work, right? I guess I talk to them enough. I need to start learning at least the common names that come up, the AE map. I have to keep that in mind. There's something equidistant map. All right, so let's see what Grayson has to say.
Least dense, therefore lighter per volume. Therefore, in simple terms, we can describe weight, the defining word.
Let's go sit back, take a sit back.
A couple of minutes left to go, so
I'll
leave it there.
Yeah, I was going to say, you've only got 10 seconds, so that's probably a good place to wrap it there. Modern day debate, and we do hope that you out there, it'll be asked. There you go.
Okay, sorry about that. Hi, I'm Grayson. My YouTube channel is Based Theory, where I do debates against all kinds of pseudoscience, religion, and I also am stepping into politics a little bit for 2024, so look out for that. Anyways, today is sort of a last-minute debate on gravity, so I sort of, in the last hour or two, I kind of put together a little presentation, so let me just share that. So okay. you all can see my screen and everything?
Yep, we're good to go.
Okay, perfect. So yeah, just want to start out talking about like what is gravity, because I see a lot of people confused about what this is. So there's two answers.
Here's the thing. I think I'll talk more on his side. He's going to explain this. But I've seen this explained several times. It's just flat earthers are dishonest. You just explain stuff and they just deny it and just hope they could find somebody else who's ignorant of it, so that they could just pretend like what they're saying it has any relevance again. But hopefully he gives a good explanation. At the least we can say that the flat earth Aussie starts trying to say, for instance, that Newtonian gravity is some kind of way. What do they say? Like I've seen them highlight this, cherry pick, as they say, this little sentence where a guy was saying that relativity supersedes mass attracts mass, but then a bit later he clarifies that it's boat work, that it's everybody understands, like he'll point out it a bit. The flat earthers, it seems like it's their MO to just try to find somebody who's ignorant, and if they find somebody who's ignorant, they just ignore all the things that make them wrong and just pretend like their point is still valid. And if you point out that their point is invalid, they just run to another subject, but then they go find somebody else who's ignorant of it, and then again pretend like their point is valid. So on the flat earth side, I doubt this explanation again is going to make any difference, but it'd be interesting to see if he how he breaks it down. So
people confused about what this is. So there's two answers. In Newtonian mechanics, gravity is an attractive force between masses. This can be measured. You can measure this gravitational force in newtons, which is the unit of force. You can do this in a number of different experiments, but most famously, a type of experiment called the Cavendish experiment. Now, I know that just saying the Cavendish experiment is triggering to a lot of flat earthers in the audience, and they're all, spurging out right now in the live chat saying, oh, actually, the Cavendish experiment, don't you know? I'll go toe-to-toe with anybody on the Cavendish experiment. That might get brought up since it is just a direct measurement of gravity in newtons as a pseudo force. We now understand gravity to be a pseudo force, but that doesn't mean that you cannot measure it in newtons as a force. Pseudo forces like centripetal and centrifugal forces can still be measured in newtons as forces. So that's one way to measure gravity. That's the end of the debate, right? I just measured gravity. You can isolate this. You can do a Cavendish experiment that is isolated from electromagnetic forces. I'd be happy to go over one such example of that, but you can do it in a Faraday shield. You can ground it. You can discharge the surface. You can essentially eliminate electromagnetic interference in this experiment, and you can just measure gravity directly. That's the end of the debate. You've measured gravity. But let's move on to our actual current understanding of gravity in general relativity. So this is not like the end-all be-all. Maybe one day we will have an understanding of gravity on a quantum level, but right now, general relativity is the current consensus theory for how we understand gravity. Now, this is not to say that Newtonian mechanics was wrong. It still gives us the correct answers. It's just that it's incomplete in what its understanding of gravity is. In general relativity, we understand that gravity is the curvature of space-time. So that's kind of what that picture here is illustrating in 3 dimensions as space-time is curved. But, what does that actually mean? How do we know that space-time is curved and that is what gravity is? Well, we make testable predictions. General relativity makes predictions. We test them and we see, hey, if gravity really is from the curvature of space-time, like general relativity is saying, its predictions should be accurate. And that is indeed the case. So I'm just going to go over 2 quick examples. The first one is called, it's called gravitational redshift. It's essentially time dilation with height in a gravitational field. So This is the paper that showed this on a really, really small scale, like just within a millimeter difference of height. So you can see here in the picture, there's that little capsule. And there's different tiers in this capsule, like the rungs on a ladder that you can see. And there's atoms at these different rungs, and they tick at a set frequency. And if the capsule is just on its side and they're all at the same height, all of the atoms tick at the exact same frequency. But as soon as you move that capsule to be vertical and the different atoms are at different heights, all of a sudden the ticking is not in sync. The ticking is going to be a little bit different for the ones that are higher up than the ones that are a little bit below. And that's because the strength of gravity is different for the ones up here versus the ones down here. And that is measurable and that is predictable. And you can use general relativity to predict exactly by how different those two ticks of those frequencies of that ticking of those atomic clocks could be. And the prediction is precisely matching with reality. General relativity tells us exactly how these two things should be different. This is literally a time dilation effect, a change in the passage of time. And it's exactly predictable using general relativity. If gravity really is the curvature of space-time, it tells us exactly what this should be, and we measure it and find that that is the case. The second example, so here's how we really know that it's spatial curvature, right? You could say maybe that's just a lucky guess.
I'll give a quick comment on that. Oh, that's pretty good. I wasn't aware of the time dilation experiment there. Sounds like he actually understands the experiment, like he actually read the paper rather than how flat earthers do. It was like search for a title that seems to say what they wanted to say and just assume it says what they wanted to say, and then lie and say it does. But that seems like a pretty cool experiment. So apparently, uh, on an atomic level, even that small of a distance experiences a different than the passage of time uh, from gravity. So that would mean technically that the time at the level of our head is going differently than at our feet. But so just on the cellular level, the difference is so small that we can't tell, but on the atomic level, uh, makes a difference. That's pretty cool.
Tells us exactly what this should be, and we measure it and find that that is the case. The second example, so here's how we really know that it's spatial curvature, right? You could say maybe that's just a lucky guess, right? But how do we really know? Let's look at another much more impressive prediction here. So this, we're going to be looking at LIGO. So general relativity predicts that when two massive objects like black holes or neutron stars, when they collide, a wave of space-time curvature should be emitted and travel to us at the speed of light. But here's the thing, is that astrophysics actually predicts that the gravitational wave should hit us first, before the actual burst of light from that event. And this is just because of the dynamics of emission and absorption and everything. The gravitational wave should hit first. That is a testable prediction. First, we have to build a gravitational wave detector, though, and that took a long time. So this is what we built. It's called LIGO. It won the Nobel Prize in like 2017 or so. Basically, there's two massive arms of this experiment, and you shoot a laser, and they're at 90 degrees to each other. And you shoot, and if there's even a little bit of difference in the space-time, like the actual length of these two arms, they're 4 kilometers each. If there's even just a little bit of difference, you measure that. And
So let's take
so
a
you
look
can
at this
tell,
image real fast. So at the top, he has gravitational waves, two black holes orbiting each other. So space-time itself is the grid there, looking here. So one laser light is sent into the instrument to measure changes in the length of the two arms. In my modern physics class, there's actually people at my university at UT that instrumental in this project. So he was able to interact with them. My professor, he was able to interact with them and learn some details about how it works. And they actually have, I don't remember the details now. The professor was we were just having like a casual conversation in the laboratory. And we happened to talk about LIGO. And he was saying how the, and actually it started before that in our actual Friday class when he was going over different principles. He was talking about some of the principles at play in calculating errors and how it goes into LIGO. Suffice it to say, he was saying how the laser is not like they just send a laser, like there's this chamber with a lot of reflective material, and the laser bounces back and forth so that it builds up a lot of light, and they could release that light to have like they do it in such a way to where the amount of energy that they have to work with is many more times the amount of the actual laser that they're using. But I only heard him talk about it once. I haven't read the details of it myself, but it was pretty interesting. He also talked about how it was built. So other details I may mention another time, but it was pretty cool. All that went into how this thing was built, and it was pretty amazing. And to think that we have stuff like this in flat Earth is in such denial and such delusion, they just dismiss it. It's amazing.
If a
Oh,
wave
let me finish reading this. That threw me off on a tangent when I saw the laser light. The laser light is sent into the instrument to measure changes in the length of the two arms. First thing that happens, we have a mirror up here, 4 kilometers, 4 kilometers. The laser back here. A beam splitter splits the light and sends out two identical beams along the 4 kilometer length arms. So the beam goes both ways, bounces there, comes back. 3, the light wave bounces back and returns. As I said there, a gravitational wave affects the interferometer's arms differently. When one extends, the other contracts as they are passed by the peaks and troughs of the gravitational waves. So it seems like thinking about like what is it called? The double slit experiment with the um, how different waves can constructively or destructively interfere. Even if one wave comes, if it hits this mirror first, the left mirror, and then hits the right mirror second, the phase difference seems like it'll cause a similar thing where they're not in phase, sort of like a constructive deconstructive thing. Adapting away differently. Normally the light returns unchanged to the beam slitter from both arms, and the light waves cancel each other out. So the where the mirror is set up, they come back at a different phase and cancels completely, right? If the arms are disturbed by a gravitational wave, the light waves will have traveled different distances. Light then escapes through the splitter and hits the detector. Hmm. So that means that if LIGO is running and there's no gravitational waves causing a difference in length, they have it set up so that no light makes it to the detector. So they send a laser beam, but nothing. Is almost like if you have a mirror in front of a light, but nothing. I guess maybe a better example would be like a piece of paper in front of the light, but no light is hitting the paper. But when LIGO causes the different arms to have different lengths, the light doesn't come back, and I guess that was a good analogy to use. Here there's 100% deconstructive interference, but if they offset some, there's not a complete deconstructive interference, so some light makes it through, even though it might be not as bright, and that's how they know that there's been a stretch. It gets more complicated than that. Like I said, my professor broke down some of it, but it was like a light conversation. He's not an expert in that either. He's he's going to retire soon. I don't think he even does research on his own himself at the moment, but I'm sure he did some good research in the past. You don't get to UT as a professional unless you're real good at researching. So so yeah, well, I guess maybe there's a few positions that don't research, but most of them. So that's that. Just reading through this image to see what it says. Let's go through and see what they're talking about now.
Of space-time comes, and basically things are getting a little bit longer and shorter and waving in space-time. You can detect that with this equipment. Here's an actual picture of it from a helicopter. This is the one in Washington. You can see that's 2 4-kilometer arms. That's 2.5 miles. And then I actually visited LIGO in Louisiana. That's me there on the right. You can see I'm at LIGO at one of the detector arms. And on the left, that's inside the control room while it is operational. So you can see that everything is lined up. The lasers are in a straight line. This also, just coincidentally, this LIGO also debunks flat Earth because the construction is basically impossible to do on a flat Earth. So we could talk about that some other time. I know that Ross said that this is a flat Earth debate. It's not actually a flat Earth debate. It's a gravity debate. We'll see if we get in that territory, though. So here's the kicker. They used that LIGO.
I can actually agree to an extent with what you said because I think it's pretty safe to say that gravity being as we describe it, the Earth can't possibly be flat because the Earth would, if the Earth were flat given its size, it would, you know, constrict into a globe because of the gravitational forces. So gravity can't be what it is and the Earth be flat. So I mean, I can see his point, but also I can see Grayson's point as well. I mean, specifically, they are debating gravity. So the fact that gravity is integral to the shape of the Earth doesn't make the debate not a gravity debate if they're going to debate gravity. But I do see what Aussie is saying, how it is integral to the shape of the Earth.
Observation to actually detect a merger of two neutron stars. They detected that gravitational wave in both Washington and Louisiana. So they knew that that was just not just noise. They were actually detecting something real, and the signal looked the same in both. And then, just like they predicted, 1.7 seconds later, a completely different detector on the other side of the world saw the light that was emitted from the exact same spot in the sky. They said, look, gravitational wave, we detected it from right here in the sky. So we predict that there should have been a gamma ray burst from the same position. And what do you know? 1.7 seconds later, there was. That is the gold standard of scientific confirmation. A testable, falsifiable prediction was made and confirmed precisely.
Whoa, spin fire. Grayson spin fire. I like Grayson. I mean, let's read this abstract. His paper is GW170817, Observation of Gravitational Waves from a Binary Neutron Star in Spiral by B.P. Abbott and al., LIGO Scientific Collaboration and Virgo Collaboration from 2017. This is an awesome experiment. I might use this one in one of my debates or talks or something. In August 2017, the Advanced LIGO and Advanced Virgo gravitational wave detectors made their first observation of a binary neutron star in spiral. The signal GW170817 was detected with a combined signal-to-noise ratio of 32.4 and a false alarm rate estimate of less than 1 per 8.10 to the 4 years. It seems like they're saying only, what, 1 in 80,000 years would they get a false alarm like that? We infer the component masses of the binary system to be between 0.86 and 2.26 solar masses. So that MO is solar masses in agreement with masses of known neutron stars, restricting the component spins to a range inferred in binary neutron stars to the range inferred. We find that the component masses would be in the range 1.17 to 1.60 solar masses, with the total mass of the system being 2.74 plus or minus that amount. Now, it's interesting that they have a different plus and minus, so that seems like some pretty, you know, specific error margins there. That's pretty legit right there. When I do my error margins, as you'll see whenever I give my talk, we just do plus or minus the same, like plus or minus 0.5 meters or whatever. They're like plus 0.04 or minus 0.01. That's legit. I don't even know how they did that. The source was localized within the sky region of 28 degrees with a 90% probability, which in astronomy, that's pretty good. So I learned them so far in my astronomy uh, 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 tenure that error margins of 10% are pretty good in astronomy. And had a luminosity distance of 40, and it would go again with the double pronged error, plus 8 or minus 0.4 megaparsecs, the closest and most precisely localized gravitational wave signal yet. The association with the gamma ray burst GRB 170817A detected by Fermi GBM 1.7 seconds. Okay. The association with the gamma ray burst GRB detected by Fermi GBM. So there's a Fermi 1.7 seconds after the coalescence corroborates the hypothesis of a neutron star merger and provides the first direct evidence of a link between these mergers and short gamma ray bursts. It's awesome, just like you said. Subsequent identification and transient counterparts across the electromagnetic spectrum in the same location further supports the interpretation of this event as a neutron star merger. This unprecedented joint gravitational and electromagnetic observation provides insight into astrophysics, dense matter, gravitation, and cosmology. Oh my gosh, that is neat. I'm about to find this paper and check this paper out. This is awesome. So, interesting thing is, flat earthers, I noticed they only read like currently they do some kind of word search or something just to try to find the name of some people that matches. If they even do that, like apparently Witsit one time just did like a chat GPT thing where he just got some fake papers. You could see the documentation of it on MC Toon's channel. Uh, but even if you read just the abstract of this paper, it's clear that it's saying what it's saying. That's why I notice PhD Tony sometimes, or maybe it's MC Toon, one of the two. They'll go to a conclusion of a paper and read the conclusion and see how the conclusion is contradicting what the flat earthers say the paper says. I mean, I remember MC Toon doing this, and he's like, "Well, where in the paper does it contradict his own conclusion?" Like, you know. So, but flat earthers are goes, like I said, they just go by the title, even if you read the abstract, which gives sort of a synopsis of the paper. Even that doesn't comport with what they want to believe. But this was an awesome paper, awesome experiment. I have to check this one out.
Falsifiable prediction was made and confirmed precisely. So yes, in conclusion, gravity is real, and we know this because of the numerous tested, confirmed predictions of general relativity, of which I only just highlighted a small subset. There's gravitational waves, gravitational redshift, like we talked about, but there's also gravitational lensing, the precession of the perihelion of Mercury, which was predicted back in the early 20th century. There's cosmological time dilation, where literally the farther things are away in the sky, the more...
I have to say again, Grayson is spinning fire. He's doing awesome. So he presented one piece of evidence in relative detail, explanation, pictures, live pictures of him being himself, a paper detailing it, and now he's giving a sort of summary, or I guess you could say overview, of several different types of similar evidences. So that's awesome.
And we know this because of the numerous tested, confirmed predictions of general relativity, of which I only just highlighted a small subset. There's gravitational waves, gravitational redshift, like we talked about, but there's also gravitational lensing, the precession of the perihelion of Mercury, which was predicted back in the early 20th century. There's cosmological time dilation, where literally the farther things are away in the sky, the more slow motion they are moving. Explain that one with relative density, I dare you. There's Einstein crosses, like are in the picture here, where you literally see the same star multiple times in the sky because the light has been lensed by gravity in a way that is impossible for traditional optics to lens that light. This cannot be explained with relative density. So yeah, usually we get a different explanation from the flat earthers, like relative density or blah, 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 but there's issues with all this.
And look, I see. This must be later. I forgot. This is still going on, so we're seeing some of the later chats. I imagine. Let me turn on the time. Oh, y'all can't see that. There's a chats on the side, but yeah. But it's not showing it right now anyway. So maybe I'll try to put the chats. Well, it's not going to make a difference because we're not seeing the chats that's happening at the time. But somebody basically asked Grayson, how was the curvature of space-time manipulated as an independent variable in order to conclude its assumed effect? So consistent with the flat earth ignorance or dishonesty, where they either just too ignorant to properly ask questions about what's going on, or like I said, like I alluded to earlier, things have already been explained to them, but in their dishonesty, they just deny the way things are really worked, are really understood, and still just fuel their delusion by asking unrelated questions. So it's interesting to see the consistency.
Density. So yeah, usually we get a different explanation from the flat earthers, like relative density or blah, blah, blah. But there's issues with all this, namely that they assume a direction. They assume gravity is down. They assume it's a 9.8. They can't explain where that number comes from. And yeah, they just they beg the question from the start by assuming the direction for this. So we're going to have to get down into that fact, explain why gravity absolutely cannot be relative density, and why it cannot be electromagnetism, like some other flurfers claim, and why it has to be the curvature of space-time because of the wealth of testable, verified predictions that have been made using general relativity. So let's get into this. Thanks.
All right. Well, thank you so much, Grayson, and also to Iron Horse for your introductory statements. We are going to move.
Hey, that was some good openings there. That, at least when I say good openings, Grayson was pretty awesome. So yeah, like I said, he had a specific piece of evidence, went into detail on, had an overview of several other similar instances. That's legit. I like it. I'm pretty sure I'll make use of that particular experiment in paper.
Into an open dialogue. So if you haven't already hit the like button, definitely give it a good smack. And also, once again, we are going to be doing our Q&A. Last little bit of housekeeping I always like to throw in there too is all the debates are uploaded. You're hearing to the hand it over to
A bunch of gobbledygook.
to some of what you just heard.
Okay, well, I did hear a bunch of gobbledygook. Starting with Cavendish, he says it's an experiment, whereas technically really all it is an observation. When we've got something such as a torsion bar with two weights suspended, one on either end, it can be said to never be perfectly at rest in the first place, and so it's just inevitable that it's eventually going to come to rest. You actually said that it measured something, that it measured it in newtons. Can you please describe to me how it measured this, and don't just say it, tell me that it was. Tell me how it was measured and what was measured.
Okay, so it is an experiment, the Cavendish experiment. There's an independent and a dependent variable, okay? So the independent variable that you are altering that makes it an experiment is the distance between two masses, okay? You have two little sample test masses and you vary the distance between them. That's the independent variable. And then the dependent variable is where you measure the force that is between them as it changes with that changing distance. So there's the independent and dependent variable of your experiment, and that force is measured by the torsion balance bar, which can actually measure in newtons whenever you apply a torsional force to the bar.
That described nothing, because
I just answered your question fully.
The whole idea of it is that those things are attracted to larger masses nearby, not towards one another.
No, that's actually incorrect. They are attracted to each other. That's the experiment.
No, it's not.
It is.
I'll
share my screen. I would like to show you an example of the setup for this experiment here.
I know the experiment quite well.
Based on what you just said, it's clear that you don't. So let me share my screen.
It would be the equivalent of saying if you had two large cranes next to one another suspending big steel balls, that as they got reasonably close to one another, both the balls would be attracted to one another. That is not the Cavendish experiment.
Here's the experiment. Here is the experiment. This is the Cavendish experiment. This is the smallest version of the Cavendish experiment ever done. These are masses on the size of milligrams, and they are measuring the force of attraction between these two tiny little milligram masses. These two masses, these gold balls. You can see them here. This is an actual picture of this setup. So you have
it's actually not the two balls on the torsion bar being attracted towards one another, as I just told you.
Look, this ball, okay, is not being attracted to this ball. It's this ball right here. You can see my mouse, right? This ball is being attracted to this ball. These two are the balls that we are measuring the force between. The one
so one of those balls is stationary.
Hold on. Let me just get this out. One of the balls.
Well, you just said that the ones on the torsion bar were attracted to one another. So you completely.
Okay. If that was what you understood of what I was saying, I apologize for miscommunicating. That is not what I was saying. Let me explain what I was saying.
Apology accepted.
I'm trying to explain it, Iron Horse here. This ball right here. We are measuring the attractive force between this one, MT, and MS for this ball over here. Are we on the same page now?
Well, that's what I said from the start. That's what I'm asking you about. What force are you measuring and how are you measuring it?
That's what I've just been answering. So we're measuring the attractive force between these two masses here, and we are measuring it based on right here, you see that there's a little center of this bar right here. You're measuring the amount of torsional force detected right here. That is
and
what a dependent variable.
What instrument measures that force? That's what I'm asking. That was my question.
The torsion balance, this little string right here, is a measure of torsion that you can measure the torsional force. Or you can also, right here, what they've done is set up a photo.
Up and down.
They measured it in two ways. Okay, let me explain. They used a photodiode right here that bounces off a little mirror, and you can measure the amount of deflection, which then you can calculate what is the amount of force that is being felt by this torsional bar. There's two different ways to determine it.
How does that measure a force?
It's literally the instrument, and you get a number back that gives you a force recorded in newtons. This is a fact. Look, here's their data right here. Like, they're measuring the displacement of the bar right here, the displacement as measured by this photodiode, versus the frequency of moving. They're moving this back and forth, this first mass back and forth. That's the independent variable, and they're measuring the amount of force right here. You can see the
Check this out real
force.
fast. The rotation of the torsional oscillator, measured over a period of 13.5 hours, is calibrated as a test mass displacement, blue, and respective exerted force, light red. The measurement is limited by both thermal noise dash and, well, maybe this doesn't seem to be part of that. Oh, okay, maybe it is. And during any varying white force noise between 100 millihertz, while white displacement readout noise dominates above. The torsional motion is decoupled well from other oscillator modes, starting at 0.5 hertz. Okay. So we have displacement, thermal noise, this dotted line here, readout noise, force signal. So this seems to be the force signal and force residuals. So there several seem like very precise measurements going on.
Is right here marked on their actual graph here, their data. They're getting a force in newtons as the as the dependent variable. This is the experiment.
Okay, so I understand how a scale works. You know, it's sort of like a resistance measurement force. So, you know, when it's got no weight on it, it measures at zero, so it's grounded. So you put a weight on it. We can physically measure a weight. What instrument are they using to physically measure this force?
Again, they're measuring the calculation with the photodiode and then using physics to calculate what force is being felt by that torsion bar.
Okay, using physics, but what is the instrument, please? One more time. What is the instrument they're using to measure?
Photodiode is one instrument, and the second
is Grayson explained this. I don't know how many times already. So this seems to be. I don't know if he just can't understand, but I noticed that it's pretty consistent with flat earthers. Like they just ask questions and that's their evidence that stuff is wrong, even though if it's been explained to them several times. In this case, literally minutes ago to me, or they ask how does this work or how does that work, when there's literally tomes of books written about specifically exactly how things work. I started calling them out on this in one of the flat earth servers I was talking on for a while before they got too rude and I left. And one of them had to admit, oh, well, I'll actually go read. I'll go read about it. But I wish I would have asked why he didn't read about it yet. Why are they sitting there saying, how does this work? How does that work? And they just don't go learn how it works. They don't go actually get one of the textbooks. So it seems like they just got under this delusion where if they just pretend like there's not an explanation out there and just keep asking the question, it means that they're right. So it's like it seems the flat earthers just happily live in this delusory world where they just deny all the answers to these questions that are out there and just keep asking the same questions over and over. So that's my encouragement that we start calling them out on that and asking them, you asking this question, are you aware that there's like literally textbooks that's, in classes around the world that literally explains that in detail? Why haven't you went and got one of those books and read it if you really want to know the answer? Why are you sitting here asking the same question over and over that's been answered 1,000 times? In this case, um, it's hard to say. I mean, maybe he just has his own delusional mindset that he's right, and he just not allowing the explanation to penetrate. It just can't get through. So maybe in his mind, he sincerely hasn't heard an explanation yet, even though Grayson has explained it in detail several times. So let's see how Grayson explains again when he's asking the same question. I don't know, 5 times now. Let's see.
Is being felt by that torsion bar. You
Yeah,
can
it's
also
okay,
do
using
this.
physics, but what is the instrument, please? One more time. What is
A
the instrument they're using to measure
photodiode
that?
is one instrument, and the second
That's a light
instrument is the
detector.
torsion wire. Have you ever experimented? Have you ever used a torsion wire, Iron
A
Horse?
torsion wire sounds to me just like a plumb bob. It just measures
No,
the universe
it's
up
not.
and down perpendicular force to the surface of the ground.
You can use a torsion wire to measure the amount of torsion in newtons as a force. Like, I'm sorry that you don't have experience with torsion wires and photodiodes, but it's not my
But
responsibility.
the whole
that you don't
point of the
understand
Cavendish
instrumentation here.
experiment, the whole point of the Cavendish experiment is that it's perfectly balanced. Hence, it's a torsion bar with a weight on either end. What exactly are you measuring? And how are you doing it?
Explained it. Oh, okay,
I
literally,
You
believe
did not
he
measuring
explain
just,
anything. You
I
said a
believe,
photodiode. That's
Flat Earth Aussie, Iron Horse just said that the torsion wire is basically like uh, uh, just a plumb bob, just a wire that hangs. So, like I said earlier, it seems like one of my possibilities for what's going on, what seems like is happening, is that he just it just can't penetrate his delusion. He's already decided what the answer is, even though he's asking the question. It's a dishonest question. He's already decided what the answer is. So in very classic flat Earth delusional discussion, he's asking a dishonest question when he's already decided the answer, and him asking the question means he's right. He asked the question, so now he's right. Whatever you say is wrong because he's already decided what the answer is. He's just asking just to show that you're wrong because he's dishonest, because he can't ask an honest question. That's what seems to be going on here.
it's like a camera uses. You know, you're measuring light.
You start in a balanced state, right? Where the forces are balanced. And then you introduce another mass, which then has an attractive force with one of the ends of that bar, and you are measuring the amount of torsion that is introduced to that bar. That is what you are measuring, the torsional force. Can you get
But
that
you're
through?
I'm gonna back it up. Let's hear
not-
it again.
Forces are
You know, you're measuring
Look,
light.
you start in a balanced state, right? Where the forces are balanced. And then you introduce another mass, which then has an attractive force with one of the ends of that bar, and you are measuring the amount of torsion that is introduced to that bar. That is what you are measuring, the torsional force. Can you get
But
that
you're
through? your head?
still not explaining how it is being measured.
I've gone
Oh
over
gosh. How many times has Grayson explained this? He even showed an image, a diagram, very clearly. Let me just I don't want to lose track of where I'm at, but let's go back to the image there. So he showed an image of an actual experiment. He pointed out that one, this photodiode can very precisely track the angle. And then we have the silicone fiber, which will, since it's a torsion measure, would have a certain amount of force will cause it to spin by a certain amount. Thus, you can see how much it spins to see how much force there was. Pretty simple. Give an explanation, has an image from a paper, and still, Federal Aussie is asking the same question again and again and again.
the forces are balanced. And then you introduce another mass, which then has an attractive force with one of the ends of that bar, and you are measuring the amount of torsion that is introduced to that bar. That is what you are measuring, the torsional force. Can you get
But
that
you're
through? your head?
still not explaining how it is being measured.
I've gone over it multiple times now. What do you want from me? I've
Well,
explained to you
you're
how they've
obfuscating
measured
it.
it
You're
in
just
two
saying, well,
different methods.
physics does it and
All right.
light does it. You know,
Let's-
like you've mentioned nothing.
Like, do you want to read through this paper? I can send you the link where they go through their entire methodology, and you can go to your heart's content, and you can get all the answers, all the questions answered that you want.
Well,
They
but you're the
measured
ones
a
explaining it.
torsional
I just
force
want
in
a simple
newtons.
layman's terms. What device are you using to measure this force? And you can't
A
give me one.
torsional
You're talking about
wire and a photodiode laser. Am I speaking English?
diode laser. Okay. All right.
Am I
Well,
speaking English
obviously you
to
don't
you?
know that.
Are you not picking up? Like, do you doubt this experiment? Are you saying that this experiment is a hoax or it's not real? Or
I
by
believe
fire.
Iron
What you
Horse
want?
actually
Well,
said he
you're
didn't
the
do
one
anything.
explaining it.
Get all the answers, all the questions answered that you want.
Well,
He
but you're the
measured
ones
a
explaining it.
torsional
I
force
just
in
want a simple
Newton.
layman's terms. What device are you using to measure this force? And you can't give me one.
Torsional
You're talking about
wire.
He literally said,
terms. What device are you using to measure this force? And you can't give me one.
Torsional
You're talking
wire.
wow. He literally said he can't give him one device that he's using to measure this force, and Grayson gave him two. So it seems confirmation of the delusional thinking, like it just can't penetrate and he's if you're new to people believing in flat Earth, he is he's he's a good example of the way flat earthers think. It's not like this is just one crazy person amongst the flat earthers and they're more reasonable. He's a good example when you try when you because they ask the same questions over and over again as if you didn't talk to them at all. And it seems, I mean, some of them it seems like they're just dumb. They just can't understand it. Others, they just the delusion it doesn't allow them to learn. They don't want to learn. They want to believe that there's no answer, so they can continue with the delusion that the earth is flat. So they can be an answer to questions, but they just deny the answer you give them and just pretend like you didn't even give them an answer, as we're seeing here. So it's amazing. This is amazing, psychologically speaking.
And a photodiode laser. Am I speaking English?
Diode laser. Okay. All right.
Am I
Well,
speaking English
obviously you
to
don't know that.
Are you not picking up? Like, do you doubt this experiment? Are you saying that this experiment is a hoax or it's not real or what?
Well, absolutely, I am actually, because if the Earth's mass is so incredibly strong, then such a tiny ball would be insignificant compared to the Earth's downward force. That you'd need something, 10 times size of an elephant to create the slightest little effect against Earth.
Do you understand how you add up force vectors? Like, this is high school physics.
Add up force vectors.
Yes.
Something so tiny compared to something so massive creates a greater force.
No, and it's measurable. Yes, there's nothing against this other than your own personal incredulity. There's no physics against this. You are literally, if you did a force, like a free body diagram of this situation, and you drew each force that was affecting this mass, you would account for the Earth's gravitational attraction to it on both of them, with a direction going down. And then you have a tiny little arrow going sideways, and that's what you're measuring with the torsion. You know why? Because the force of gravity is perpendicular to the direction of torsion, so it's not affected.
Okay, and it's also well known that the Cavendish experiment doesn't always work.
So Grayson knows this stuff. Now, this stuff is not really, I was about to say it's not really complicated. I guess to a flat earther it is, or to, I mean, these people don't understand basic math and science, as I demonstrated in my debate with Toby and Alan. I mean, these people, don't understand even just basic math and science. So, but you notice how he's saying, Iron Horse, I mean, is saying that the Earth would have an effect when gravity is pulling down on all the different bars equally. You're not having a transverse effect. So what he's saying is just wrong. It's just absolutely wrong. But again, he has already filled himself with such delusions and misunderstandings to where the actual facts can't get through. It's just like they're in some kind of prison, like some kind of mental prison, like the Matrix, ironically. They're in a prison for their mind with their own delusions. They just can't escape. Nothing from the outside can penetrate.
We also know that you have to invent something like 95% dark matter to explain why the universe doesn't provide.
Changing the subject. Come on.
Exactly. I'm glad he caught that. I was just about to say that. Now he's running away from the subject. I want to hear Grayson's awesome explanation one more time. Let's hear that exchange once more.
Are you saying that this experiment is a hoax or it's not real or what?
Well, absolutely, I am actually, because if the Earth's mass is so incredibly strong, then such a tiny ball would be insignificant compared to the Earth's downward force. That you'd need something, 10 times size of an elephant to create the slightest little effect against Earth.
Do you understand how you add up force vectors? Like, this is high school physics.
add up force vectors.
Yes.
Something so tiny compared to something so massive creates a greater force.
No, and it is measurable. Yes, there's nothing against this other than your own personal incredulity. There's no physics against this. You are literally, if you did a force, like a free body diagram of this situation, and you drew each force that was affecting this mass, you would account for the Earth's gravitational attraction to it on both of them, but with a direction going down. And then you have a tiny little arrow going sideways, and that's what you're measuring with the torsion. You know why? Because the force of gravity is perpendicular to the direction of torsion, so it's not affected.
Okay, and it's also well known that the Cavendish experiment doesn't always work. We also know that you have to invent something like 95% dark matter to explain why the universe doesn't provide.
Changing the subject. Come on.
Into a singularity.
All right, well, of course,
moving on. We're still
let's
talking
let him
about
finish
your
his
subject.
thought, and you can address after there. Just let's give him some space. Go ahead, Ross.
Yeah, it's also well known that you have to introduce 95% dark matter to prevent the entire universe colliding into a singularity. You have to have dark energy to stop it from spreading apart. You've got everything except visible proof of gravity. You've nothing but theoretical garb in order to make your theory of attraction even possible. As Tesla even said, there is this invisible force which everything in the universe operates by, which we can also see in things like pendulums, which change via latitude. We can see it in the star rotation themselves as the stars get further from Polaris, they move in larger and larger circles. So there is this invisible energetic force constantly surrounding us that everything responds to. And it's just as likely that the Cavendish experiment is reacting to something like that as well, like just some sort of invisible force, which it is not. Gravity is not an attraction of mass.
Wow. So Grayson literally showed an experiment where you can see the gravitational force. And Flat Earth Aussie literally said you can't or never have shown where you could see it visually. So, I mean, it's amazing. Just like how Grayson explained several times two devices that were utilized to measure the force, the photodiode and the torsion string itself. And Flat Earth Aussie said he didn't present anything, not even one device to measure. So, I mean, at this point, it's clear that it's pointless talking to this guy. And I believe it was Reddy. Reddy said Ross loses every debate he partakes in. He's uneducated, dishonest, and completely ignorant of anything scientific. You have shown yourself to be accurate in that matter already. So Reddy Greaser put that in the chat earlier, in the live chat there, and it is proving to be true. Man, so let's see. I'll keep going until the topic changes, and then I'll probably pause and come back another time. Let's see what we have.
Okay, so you're done there. You brought up a whole lot. I don't know even why you brought up dark matter, because your ultimate point didn't even have anything to do with it, but okay. I don't see how dark matter is relevant, and you got dark energy and dark matter confused in their roles in cosmology anyway, but that's fine. You just got them flipped. But yeah, the evidence supporting the existence of dark matter is like coming from multiple independent sources that all corroborate and give the same exact value. At least 6 or 7 different independent sources of methodologies to support dark matter. You have a couple for dark energy as well. Like this is not just one observation that's telling us that these things actually do exist, despite us not knowing like exactly what they are. We know that they exist from their actual evidence, from gravitational lensing, galaxies rotating, like bullet cluster. I just feel like this is just so off topic to even bring up.
Well, that's absolutely the topic, because if you didn't make up gravity in the first place, you wouldn't need to make up invisible dark forces that you can't even see or detect, but you know must be there. So obviously gravity is wrong to begin with, and we can scrap the whole idea and start with something which actually works.
So let me clarify, because that is incorrect. Even if we scrapped gravity, if we completely got rid of the entire idea of gravity, we would still have dark matter. Like, we wouldn't just get rid of dark matter by doing that. We would still not have an explanation that needs dark matter to solve based on our observation.
Please explain why. You assume everything in the universe is actually physical matter or something equivalent to what the Earth is made from. Whereas, as far as I'm concerned, Earth is the only physical plane in all of existence, and all the lights in the sky are not terra firma whatsoever. So we don't need gravity to explain why and how they exist. They exist in a different form of medium altogether once we leave beyond the firmament, which is above us, and they are in a different sort of medium and obey completely different rules. What we see and experience here in the physical plane is what we see and experience. And so we don't have to try and explain the entire universe when all we're really trying to describe is what is here and now, what is beneath our feet, what is in front of our faces, how all the laws of physics behave according to observations, as opposed to hypothetical things about things that happen beyond.
Interesting how now he's saying you don't have to explain all that other stuff, and he's the one that brought up dark matter and dark energy when they were talking about an experiment that's doable and was done right here on Earth. So it's interesting. I'll back it up for a few seconds.
Leave beyond the firmament, which is above us, and they are in a different sort of medium and obey completely different rules. What we see and experience here in the physical plane is what we see and experience. And so we don't have to try and explain the entire universe when all we're really trying to describe is what is here and now, what is beneath our feet, what is in front of our faces, how all the laws of physics behave according to observations, as opposed to hypothetical things about things that happen beyond the curve where we can't see them, out of sight, out of mind, beyond this curve, which we've never seen.
I was trying to let you finish, but you never seem to finish. But okay, it is actual observations that you need to explain. You can't just say, well, we don't need to explain actual observations of the universe because, like, we're only concerned with what's happening here. Again, like, you were the one that brought up dark matter. And now when I bring up observations that you need dark matter to explain, all of a sudden, oh, I don't care about those observations. We only want to talk about what's here on Earth. And now it's a flat Earth debate. Okay.
Grayson's doing good. He's calling out the bullshit. So when Grayson was killing him on a local experiment, Flat Earth Aussie ran to dark matter, dark energy, because of course the Flat Earthers, he's just repeating the common Flat Earth delusional talking points. How it's just made up to explain stuff. So now when Grayson is showing he has knowledge of the experiments that demonstrate that, dark matter wasn't just made up, dark energy wasn't just made up. It is based upon observations and evidence, on experiments, on evidence, observations. Now all of a sudden, we don't have to talk about that far stuff. Let's just talk about here. But if he really believed that, he would have just kept talking about the local experiment. So you can see how these people just run around to whatever they can delude themselves into believing they're right about. Is amazing. Let's go back again and hear Grayson call them out on that.
The observations, as opposed to hypothetical things about things that happen beyond the curve where we can't see them, out of sight, out of mind, beyond this curve, which we've never seen.
I was trying to let you finish, but you never seem to finish. But okay, it is actual observations that you need to explain. You can't just say, well, we don't need to explain actual observations of the universe because, like, we're only concerned with what's happening here. Again, like, you were the one that brought up dark matter. And now when I bring up observations that you need dark matter to explain, all of a sudden, oh, I don't care about those observations. We only want to talk about what's here on Earth. And now it's a flat Earth debate. Okay, I thought you wanted to talk about dark matter, so let's talk about one observation that you can't explain. The bullet cluster. Are you familiar with it?
I'm not familiar with the bullet cluster.
Okay, so it's one observation that cannot be explained by any theory of electromagnetism or any theory of modified gravity. You need dark matter to explain the behaviors of the bullet cluster. What happened is these two galaxies, like, literally were on a collision, and the actual movement that they had when they were colliding, okay, it cannot be explained with electromagnetism, with relative density, with some sort of ether. You can't explain the way that it's moved, except for if there's an invisible dark matter component, which you can actually literally see where its density distribution would have to be in order to get this sort of movement. Because what it looks like is happening is that these two galaxies are moving around nothing. It looks like there's some invisible thing that these galaxies are moving around and feeling a force from. But if you don't have dark matter, there's no explanation for it.
Okay, well, that's a cool story, bro, because I wasn't talking about other galaxies and so forth. I mean, even our nearest star, according to, heliocentrism, is, some multiple light years away. So obviously these galaxies, each of them would still have, spaces unfathomable between one another. So anyway, hopping off completely, as far as I'm
Okay,
concerned,
no,
off
don't
topic to start
accuse me
talking
of
about
doing that.
galaxies.
You were the one that brought up dark matter, and this is one
Yeah.
of the pillars of evidence supporting dark matter. You were the one that said, without gravity, we don't need dark matter. I am bringing this up as an example to clearly show that even without gravity, you cannot explain the behavior of the bullet cluster, which requires dark matter. This is a direct refutation of your point. You brought this up, not me.
Yeah, but you're making the assumption that these galaxies are physical matter in the first place, and that they
We can
behave
look at
in
their
the same sort of
spectrum.
laws as to which we observe here on Earth, where you assume that we have gravity, and then you have to assume dark matter to stop everything else behaving because you've already assumed that they're physical stuff in the first place. Where I say there's no such thing as anything physical outside of the realm upon which we live.
Okay,
and so once you remove that assumption, then all of your pseudoscience is no longer necessary or required.
It's not an assumption. This is just a fact based on observations from like spectroscopy, for example. We can look at what elemental composition these distant objects have by their spectroscopy.
No, that's not true whatsoever. We can say that the spectroscopy is entirely due to the atmospheric gases and the way these things stimulate it to create light visible to our eyes. So all of this could be only happening because of our observations from here on Earth looking through our atmosphere. And once we're above the atmosphere, as we see in high altitude balloon footage, there are no stars visible whatsoever. All we see is the one giant big sun, and we see a tiny dot which represents the moon, and that is all that is visible from above a certain height. So we know the importance of our atmosphere is the real giver of light, and all of spectroscopy happens as we see through our atmosphere and the various gases that are stimulated by these objects.
You made the same point multiple times. Let me respond.
Well, that's right. It's important.
Are you familiar with the fact that we have observatories above the atmosphere, like the James Webb Space Telescope, that do spectroscopy without having any atmosphere intervening? Right? There's no atmosphere.
I believe they only use radio waves. They use radio waves only, and they don't use spectroscopy whatsoever.
They literally do spectroscopy, yes. Everyone can look that up and see that the James Webb Space Telescope does spectroscopy, yes.
Yes, and NASA hires really good artists to try and turn them into pretty pictures.
Hey, what's going on, Sean G? How's it going? Good seeing you. I've been wanting to stop so I could get back to some homework, but I'm actually finding this debate pretty good. You know, I mean, I'm familiar with the other Ross with Flat Earth Aussie a bit, and he's not disappointing. I mean, it's what you would expect. But Grayson is actually pretty good. He knows his stuff, has the evidence to back up what he's saying, going to it. So it's pretty interesting. What's been going on with you, Sean G? And while we chatting, I'm gonna see if I can pull up this uh JWST spectroscopy thing. Ah, awesome. Yeah, glad you've been enjoying it. Let's take a look at this. All right, so I have this site from James Webb. See if this is showing properly. Okay. So this is the James Webb Space Telescope website. It says the near spec is designed to observe 100 objects simultaneously. The first spectrograph in space that has this remarkable multi-object capability. So it's not the first spectrograph in space, but it's the first spectrograph with the ability to observe 100 things at the same time. So let's take a look and see what near spec does. I'm just going to scroll through, get a general overview here. All right, so let's go back to the first paragraph. The near infrared spectrograph, that's why they call it near spec, I guess, operates over a wavelength range of 0.6 to 5 microns. A spectrograph, also sometimes called a spectrometer, is used to disperse light from an object into a spectrum. Analyzing the spectrum of an object can tell us about its physical properties, including temperature, mass, and chemical composition. And I'm in this paragraph here. The atoms and molecules in the object actually imprint lines on the spectrum that uniquely fingerprint each chemical element present and can reveal a wealth of information about physical conditions in the object. Spectroscopy and spectrometry, the sciences of interpreting these lines, are among the sharpest tools in the shed for exploring the cosmos. And we have this image here. So infrared sensitivity of Webb instrument, all right? So near infrared. So visible light is here. Infrared is here. Got the wavelength up here. So it's lower in frequency than visible light. No, it was a higher in frequency. Yeah, infrared is lower in frequency, bigger in wavelength. Cooler red stars, dust is apparent, planets, comets, asteroids, dust warmed by starlight. So the reason why they're going into infrared is because of the redshift. Because the farther away we look into the universe, the more the expansion of the universe stretches the light. So the light reaches us, even though it was in a visible frame when it left, or the visible range when it left the object. By the time it reaches us, and I guess technically these objects would have to be, I guess, within so many, can't be very distant because it didn't shift that much. Like if it shifted a whole lot, and I guess it would be in the radio waves or something. So these are objects that seem to be, from my limited understanding of astronomy that I have so far as an undergraduate, but definitely a lot more than a flat earther. Very absolutely ignorant, nearly absolutely ignorant. But I would say these are some near objects, like redshift less definitely, like round one maybe or less or something, um, where the light from those objects have shifted into the infrared region or near infrared region. So it's still almost visible, and we could pick these things up. We can see from the spectra that they're planets, comets, asteroids, so on and so forth. Just like how we can see hydrogen in a lamp in a laboratory and know that it's hydrogen. So this is pretty basic stuff to people who are knowledgeable even a little bit in science and astronomy, as Grayson here clearly is. Many of the objects that the Webb is studying, such as the first galaxies to form after the Big Bang, are so faint that the Webb's giant mirrors must stare at them for hundreds of hours in order to collect enough light to form a spectrum. In order to study thousands of galaxies during its 5-year mission, the NIRSpec is designed to observe 100 objects simultaneously. The NIRSpec is the first spectrograph in space that has this remarkable multi-object capability. To make it possible, Goddard scientists and engineers had to invent a new technology, micro-shutter system, to control how light enters NIRSpec. So damn, it's going all the way to galaxies that form because of the first galaxies after the Big Bang. So it seems like it does go pretty far in redshift. So I need to improve my understanding of how redshift affects visible light. So apparently it doesn't shift that much. I thought there was a bigger shift. Unless I'm just misunderstanding exactly what kind of how they're doing it. So apparently this is one of the shutters that light enters. Micro shutters. So these must be the micro shutters. So apparently each of these shutters must pick up a certain object. That's pretty neat. So we see that iron horse, unsurprisingly, is wrong. So we have a spectrograph in space, so we know that the spectra is not just from the atmosphere. We've had other spectrographs in space. This is just the first one with this capability. So awesome. I think this is a good place to stop. I think Grayson is doing awesome. I'll definitely come back whenever I'm bored or something and need a break because I did a lot of studying this week and a lot of work. I'm about to finish my French class next week. So I actually like French, but I'm liking astronomy and physics a whole lot more. So I'm actually going to be thankful to be through with my language requirement. Maybe in the future I'll pick up French, study French more, but I'm not sure if I will. So my time is limited. But I've been putting a lot of extra time doing that. My math class, I have to do well on this last exam next week. I skipped the third exam because I know I'm going to do horrible. But the last exam overwrites the third exam, so I got to do good on it. And plus, there's some stuff I really want to learn about, like eigenvalues and eigenvectors, which I'll need for quantum mechanics in the fall, which I'm taking again. So I know I could do better in it. So for this next week, probably be doing a lot of studying. I'll be back probably as a nice celebration after I take my exam. Maybe I'll be back Friday and Saturday next week, but definitely Saturday. So I've been keeping a pretty steady Saturday going, except for 1 week I was studying so much that the day got past me, and I just was here on Sunday that week. But expect me next Saturday, and I'll probably continue with this debate here because I think Grayson is doing awesome. So thanks, Sean. Thanks for you all wishes. Thanks for Spurge and Ready for joining. Everybody like, subscribe. If you haven't already, share. And let me know if anybody wants to come on and talk. Join my Discord. The link is flowing at the top. So maybe we could do some kind of panel thing or something one time. But awesome. I'll be back next time. Thank y'all for joining. And be sure, by the way, to visit the MDD debate and like over there as well. Put the link in the description. It should already be there. And I'll see y'all next time.